Yo, welcome back to my YouTube channel. Yeah, somebody asked me why I named my YouTube channel badwiki.dev, and I think to be a great programmer you need to be kind of bad in order to get good. And it's also like a play on creativity because when you're the baddest at something, that means you're the greatest. You feel me? So like that's what I'm trying to do, trying to be the greatest. So here we go. Merge array. What is it? What is the merge sorter? What is merge sorting? What is merging array? Let me just look at my notebook over here. Uh, cool. So I state here the process of merging arrays. With merging arrays, we're primarily aiming to take any number of sorted arrays and take their various sizes and placing the sorted arrays into one big array, right? Keep in mind that we are working with sorted arrays. The values need to be already in order. So I have here into array 1 and array 2, right, with various integers or just data inside of them. Let me just try this real quick. Right, so we have two arrays that have various data that is sorted. You feel me? And then with that, oh, let me not say that's kind of. But with that, we share another array. I will call this array final, which is comprised of the array size of array 1 or array A and array B. So we take those two sizes and add them together and create one big array. So with that, we need to take advantage of the fact that these arrays are already pre-sorted, right? Because it would be easy to just copy and paste those values, but like it doesn't bring us or do us justice to do so. You feel me? Because that's the wrong way of doing things like that. It's not solving any computational program or problem. You're just adding things that we shouldn't just be adding. But anyway, with insertion sort, right? With merge sort, right? We need to keep in mind that since we are working with what is now three arrays, array A1, array A2, and array final, right? So we would declare what I call index pointers because we are working also with a fundamental concept of parallel arrays where we are using multiple arrays and using pointers to their index positions to do comparisons. And the comparisons that we do within merge sort is checking whether the value, let me just check here, checking whether the value in one array is greater than the value in the other array, or if the value in the first array is less than the value in the second array. If it's greater than, if A1 is greater than A2, we are going to add the value into the final array, and we are going to increment the pointers just to change where the index pointers are pointing. That is the whole basis of merging arrays. I think that's as simple as it can get because that's what it is. That's really what it is. So let's go into code analysis. We've already covered the concept of merging arrays, and it particularly has to do with the fact that we are working with two or more sorted no, not algorithms, arrays, and our goal is ensuring that we can merge these arrays according to the fact that we are taking advantage that they are already sorted. We take these arrays and compare the values that are being stored within their respective indices, and thus ties in the concept of working with parallel arrays, as I've stated. We conduct the algorithm according to the procedures that it takes to set up. Okay, fancy English. We will use two method signatures in order to achieve this functionality, one called merge arrays and the other called merge sort. So as we've stated that we are comparing the values that are in the different indices within the different boxes that they are in, right? We are comparing and then adding all those values into one big array. So to like speed run this, I'm just going to look at the what's this, the method signature first. So here we can see we have an array called elements, which is going to store the total size of A1 and A2 And then here I have two integers called int right and int left. So int right represents the A1 array. This is going to be considered the left. You feel me? Whatever's to the left, we're going to deal with that there. Whatever's to the right, we're going to deal with that there. So we create index pointers to keep track of the indices of the arrays. Cool. And then we just set the while loop to do the merging. While I index pointer is less than left, whatever is happening in A1, we need to just add all the values that are being stored in A1 straight into the elements array, or else all the values that are being stored in A2 into the elements array. So this is a while loop. It's going to continue running until we break this condition where either of these index positions get broken. So let's say I'm working with two arrays, right? One is size 5, one is size 8. Of course, the array that is size 5 is going to break first. So while that pointer that just keeps on going and going and going right here, right? Once it's greater than the total elements of A1, we break that condition. Then we move into here, where since now we have leftover elements in the next array, we're just going to fill all those values into that particular array, which is the elements array. And we just go do that, right? Since we have left and right. The right would be the size 8 as I was talking about previously. It's like we're just going to fill all those values, then we just print out the different values that are in the arrays itself. Cool stuff. So now that wraps up the partitioning method. Partitioning is breaking something down and just dealing with it. And yeah, it's a weird way of putting it, but we're taking one big array and we're saying, okay, we have the left side and the right side. On the left side, compare the values and continue adding them into the larger array. While this condition is true, also do it for the right side. But if any of these arrays break or are full, just add the rest. Simple. And then now, since we are calling the method recursively, right? This wraps up the partitioning method. We then move into the merge sort method, where we can do the process of recursively calling the method until it fulfills the condition of the base case returning 1. This represents the partitioning returning until only one element in the array remains. Cool beans, cool beans. So here I just have an elements array, the one big array, and then the length of this array. That's the only parameters we take. So now that we're looking here, we're saying if array is if length is greater than 0, return. So if ever the length of the array itself becomes 1, this condition breaks. This is the base case. So with recursion, it's like I just need to go here, right? With recursion, we're going to keep on targeting these two methods until the condition becomes true. Until the condition becomes
The
false.
YouTube Music app can sense what you
And
like
then we do
from the
merge
moment
arrays.
you open the app.
So we don't even touch
Try
this
1 month
until
free of
all
charge.
this becomes true. And then, since we were working with the concept of taking one big array and like making one side of it the left and the other side the right, we would now have to create additional pointers, I would say. So I say here, we set 3 values as the pointers for the partition, particularly the midpoint of the larger array, right? Length divided by 2, which is the midpoint of the entire array, and then whatever's to the left is the left. So when I say here int left, it's going to be new int. So whatever goes from the beginning of the array to the middle, that is the left. And then the rest of the array would be considered to the right. And then we loop through each of the two arrays and assign their values. from the element array into the two arrays representing its halves. So here I'm just looping through the left side and saying whatever's to the left within this larger array, place it into this left over here. Whatever's to the right, this is how we denote the right, and then take those values and place them into that. And then we're going to keep on calling this method recursively until we can see, no man, there aren't any values to be sorted anymore because we have broken them down. And then we have two arrays left, and then we place left and right into the larger array. Weird picture to paint, I won't even lie. It sounds like a lot of yapping, but it makes a lot of sense once you understand what you're doing with the method. And what merge sort really does, one big array, chop it in half, sort the left, sort the right, until there's only one value remaining, and then we take all those values and then just place them into the merge array because it's already sorted, bro. And that's game. That's all I'm gonna be doing. I already have quick sort over here, bro, but like I'm tired. It's like 1 a.m. and I'm actually shooting a YouTube video, bro. But we do it for the grind, bro. We love it. I'll just go through quicksort just as like free game, really. So I say here, moving into quicksort. With bubble sort, we can note that the comparisons are very redundant because we're still going to compare values we know are in there, right? No, that's false. We don't know that the values are right. I'm just gonna move from here. So we shall move into quicksort, where the sorting process is called recursively using the divide and conquer approach. And as I stated in one of my videos, that any single algorithm that calls itself recursively is ultimately bound to have n log n time, because what the recursion does is like it showcases that we are splitting up values in order to merge them back into their original sorted array or sorted algorithm. And how I state here, quicksort primarily works with a collection of objects, and with that we're able to select any of these values at random and make one of them the pivot element. Because with quicksort, the way it calls itself recursively is like, let's say we have a collection of 100 elements, right? Within those 100 elements, we take one as the pivot. Any value that is less than the pivot will be put into a sub array of S1, and then any value that is greater will be put into S2. And then we keep on calling that function of taking that S1 collection, selecting a value that will be the pivot randomly, and then any value that's less than the pivot, S1. Any value that's greater, S2. We call that recursively until there's only one value left within the data structure. Yeah. Cool beans, cool beans. We're getting there, we're getting there. So we also need to keep in mind, okay, let me just read from here. So I spot that pivot. And the means in which we partition the elements is by checking whether any values that are smaller and larger than the pivot within the collection are split. So I would say we also need to keep in mind that with the pivot set, we can then take the collection of elements and create smaller subarrays that store values that are smaller and larger than the pivot. And since we call this recursively, we set a base case that returns the value of when this process of creating subarrays only have one element remaining. Yeah, that's beautiful, beautiful stuff. Then I'm gonna open this to the right. Right. Quicksort code analysis. So we set up the partition method, right? And what the partition does, it has three parameters: the array itself, or the collection of data, int down and int up. And as I stated, any like integer values and stuff like that, we refer to these as index pointers. So down points to the first element of the array, so to speak, which would be the value of 0, and up would be the maximum number of values that are being stored. If I had an array of 6, right, 6 elements, it would be 0 1 2 3 4 5. So it's going to be 6 minus 1. That is the the array size because it's going to iterate from 0 to 5. It's a very weird thing. I keep on getting that confused. I don't even know why. Right. So within our method, we need to set pointers to the left partition and to the right partition and the pivot element, and we do that right here. Right. Then we move into setting the logic of quicksort, where we check whether the left pointer is less the left partition partition is less than the up pointer through the use of a while loop. And yet we still need to set another while loop that implements the logic of whether the value of the left pointer is less than equal to that of the right, and the values in the left partition are less than the pivot, or that the items in the right partition are more than the pivot. For the left partition, while left, the left partition is less than or equal to right, and the items that are in the left are less than the pivot. If true, then we increment this left pointer. For the right, we check that if left is less than equal to right and elements to the right of the pivot are larger than the pivot. Beans. And then we decrement the position of the right pointer. Since these conditions have been set for the left and right partitions, bro. No. Am I wrong? No, these are pointers. Oi, watch it. So we also now have to swap any values that need to be sorted using an if statement to check whether if the value in the left partition is less than that of the right partition. So if the okay, swap. Then we finally loop through all the elements since they all should be partitioned and sorted. Then we just display the values through a loop. Then display the values. Right. Then inserting the recursive call. And what did I say about recursion? First set the base case, bro. The base case is the best case because it's like whenever we have one element remaining left, we just return that, and then recursively it collects all those inputs and then it sorts. This is just for setting the pivot index for these two quick sort recursive calls, because it's gonna keep on changing the pivots until the partitions are sorted and then yeah, I don't know, I'm still going to brush up on a lot of this, but we're getting there. I see the clear picture, and I think I'll have to like re-update all these uploads because I'm very tired running off of energy drinks, and but it's pretty cool. I'm confident in what I know, and what I don't know, hey, we love it. Anyway, I'm wrapping up the sessions. These were just me trying to explain algorithms. Leave a like, comment, subscribe, whatever you do. Click the notification, comments, tell me how you think it was. Like, I want this to grow into something big, and we're putting that seed into the universe. Thank you, and goodbye. Till next time.